Good afternoon, evening, depending on when you are watching this, and probably when I finally actually get it posted. This is September 29th. I'm going to do a quick, well, may not be that quick, but little overview forecast for the October 14th annular eclipse here. I'm going to try to make it quick, but it probably won't be. But starting yesterday, September 28th, we started getting into this 16 days away, which basically means that our long-term forecast models, the U.S. model, which is called the GFS, the U.S. GFS ensemble forecast, the European ensembles, the Canadian ensembles forecast, they all now get into the time period. Actually, the U.S. ensembles has forecasted that to that time period for a while, but you had to wait a day to actually get the data for it, for one thing. Now we're actually into the 16-day period where we actually get the data right away. So I'm just going to go through a little bit here. It's still 15 days away as of September 29th, so it's still a little too far away to really get an idea of what's going to happen, but we can make some guesses. We can start to make some guesses based on some trends and some of the ensemble forecasts, just some pretty general forecasts, I should say. And I'll make my first general forecast here during this video, but probably with the caveat that it's going to change. But given that it's October, there are some things that can be generally expected. So I'm just going to, and I haven't looked at everything here myself. I have, but I haven't looked at all the little details that I'm going to try to go through a little bit here. So just bear with me a little bit on this video, but here's the general pattern here as of, well, actually, go back 6 more hours here. As of this morning, early this morning here, I'm on the West Coast here, so when I say early this morning, that means early this morning, West Coast. Morning more to the east, we have, these are 2 different models here. This is the US model, the one that here that says GFS up here, that's the US model. And then the one that says EC, FAST, that's the European Center for Medium Range Weather Forecasting. This is just the fast version, actually. It's late enough when I'm recording this video that I can go to the regular speed. ECMWF, that's the European Center for Medium Range Weather Forecasting. That's what that stands for. So those are 2 different models. This is just what the weather pattern looked like this morning. Just in general, these in the Atlantic Ocean. Well, actually, before I point out this, here is North America. So this is Alaska right here. This is the North America map. This is Canada. This is the United States. Basically, just doing a very rough outline, obviously, but that's the United States, and then Mexico. If you just to orient you here on this image, these in the Atlantic Ocean. This is I didn't check this morning, but I assume are both tropical storms still. Tropical Storm Felipe and Tropical Storm Rina. I believe they're both tropical storms, but that's what those are, if you're curious. If you aren't familiar with these maps, anytime we have this cooler air moving south, that's called a trough, and usually that means clouds and more or less stormy weather. When we have these warmer colors moving north, that's a ridge, and we usually have a high pressure system, which is what this H is, under the ridge. These low pressure systems under the trough. The high pressure systems will normally bring the clearer weather. So over the West Coast, you currently have this trough. It's been more or less raining this week for the first time since spring, pretty much. So that's what, well, other than features such as Hurricane Hillary, for example, the remnants of that. But Anyway, this is what the general pattern looks like. Trough, ridge, trough over the west coast, and then more or less a ridge over the eastern part of the country. Ignore those sounds if you hear them during this video. As we go forward in time, this is the U.S. forecast. That trough in the western part of the country is basically going to cut off across the Intermountain West, and we're going to get a ridge that builds in here. So it's going to dry out here near the west coast. I'm actually in Oregon while I am making this video. So if I if I mention things about Oregon, you know, if I concentrate on Oregon or west of the Cascades, for example, in Oregon, while I am talking about this, it's for two reasons. One, west of the Cascades is the most questionable area along the annular eclipse umbra path, just because of the fact that it can be cloudier than any other place along the annular umbra path here in October, and also because the annular eclipse path comes ashore in Oregon. Um, so that's where I will I might focus on that. That's just because that's where I am too. But I will talk about the whole rest of the path here at times. So we have the trough here. We have a ridge moving in to the northwest, well, the whole west coast, and then a trough and moving into the central part of the country. This is as of Wednesday, October 4th, and then a ridge in the eastern part of the country. This is what the U.S. model forecasts. Let's go to European model for the same time. And you see essentially the same pattern. We have a trough, then we have the ridge a little further west there than it is on the GFS model, which is the U.S. model, but it has the ridge. It has a ridge along the east coast, the ridge along the west coast. So this basically means warmer than normal temperatures for early October in the east, probably in the west as well. And again, looking at the U.S. model is a little further west, but essentially has the same type of weather pattern. So weather pattern is pretty clear for early October, as it usually is in the short term. It's as we go further in time that it starts to deviate here. So let's see what the U.S. model does here as we go through time. It actually develops a hurricane here off the coast of Mexico. That ridge on the west coast pretty much stays there, but starts to, if you wonder what I'm doing, I'm going forward and back here. So I'm going backwards here and I'm going forwards here. It kind of maintains itself, but it starts to break down a little bit in magnitude. There's still a ridge here on the west coast. It breaks down a little bit in magnitude. Looks like in response to this energy coming out here from the Gulf of Alaska. This is now on October 8th, early morning of October 8th. I'm going to go back in time just a little bit here. Yeah, so this energy here, which is basically this big low pressure system, all this cooler air that you see in the blue, as it comes here from west to east into the Bering Sea and the Gulf of Alaska, it starts to break down that ridge that's still maintained here along the west coast. That's what the U.S. model says. 210 hours. Let's see what the European model does for the same time period. It actually does more or less the same thing. This is the same time period. So here's that cooler energy, that cooler air. I should say cooler air, but there's upper level energy. When I say energy in the atmosphere, that basically means air that's rotating. So it has some energy to be able to generate storms, air rising, and as that moves southeast, and by the way, these lows and these low pressure systems in the atmosphere get their energy from the difference between the cooler air and the warmer air. So you'll see warmer air and cooler air usually pretty close by when you see these slopes. Other than the ones in the tropics, those are different. Those are tropical storms. All right. So anyway, the European model is doing the same thing. This is at 210 hours. This is 210 hours. If I can do a quick division here, 210 divided by 24. Let me just do this real quick. 210 divided by 24. That is 8 3/4 days out. So that's almost 9 days away. And there's fairly good agreement between the European model, which you see right there, and the U.S. model. In terms of the overall setup, we still have we have this energy coming in, we have this trough, and then we still have a ridge over the west coast. Maybe not as strong as it was, but it's still there. And here's the European model, same time. Here's that trough, and here's that ridge. So we still have the same general pattern. The exact strength of these trough and ridges are going to vary a little bit. All right, I'm going to go to 240 hours, which is 10 days. This is as far as the European model extends right now, the operational European model. We do have European ensembles. Ensembles are just a collection of the same model ran multiple times to get a variety of possible solutions of what might happen in the atmosphere. And I'll show you those a little bit. But this is the European model, a forecast for 10 days away. This is the GFS model right there. So the GFS model is more aggressive with this. Nope. It's more aggressive with its hurricane moving into Mexico. European model actually does have a tropical storm. You don't see it on that image. Well, actually, you do. It's weaker and further south. If you were to go back a little bit in my video, you would see it down there, but it's already made landfall in this case, the European model. So they both agree on some tropical development there. Here is that cooler energy starting to move into the Gulf of Alaska. Here's the remnants of that trough. And now our flow, the wind flow, if you just follow the lines in between each of these colors, is more west to east, right over the northwest. We call that zonal flow. It's more west to east. If you look at the U.S. model, I kept my the annotations on here for a reason. You see, it's pretty similar. Here we have our trough a little bit elongated. We have our low there. The remnants of our trough is slightly further east, but this is actually pretty really good agreement for 10 days out, which is kind of surprising to me. But the U.S. model does have a little bit of a ridge here along the west coast, which means our colors are kind of pushing upward just slightly right along the west coast. That's just the remnants of this ridge that's going to build here this coming week. So let's see what the U.S. model, this is from this morning, does as we get into the extended period beyond 10 days. It brings some of the energy from right here. It's hard to see, but if you look at the cooler colors, it kind of dip southeast a little bit here. If you look at the black lines, they also dip south just a little bit offshore. Those black lines are actually sea level air pressure. So there's a front right here. So there's a cold front here moving into northwest. Remember, this is a forecast. This is for 11 days out by the United States models. This is going to change a little bit, obviously, but it has energy moving east, and it tries to build in another ridge right there. This is for October 11th, which then moves east. And this morning's model run tries to build in another ridge behind it. This is for actually the time of the eclipse. Actually, at this point, the eclipse reaches its maximum down here off the Yucatan Peninsula, so it's basically over in the northwest by this point. But just a few hours earlier is when it'll be over the northwest. So if this morning's U.S. model is correct, we could see a potential for some clear skies across most of the eclipse path. But that's just one model run. Like I said, the European model doesn't go out further than that. If we look at some past runs here for the same time, this is okay. So this is yesterday afternoon, and we see something completely different. We see this a lot of energy in the upper atmosphere moving through the western part of the country. If we go to yesterday evening's forecast, we see a ridge just off to the east of the northwest and to the western part of the country. So you can see here how it's different between every model run. Lots of probable clouds over the northwest here from over the overnight model run from last night, and this is this afternoon's model run, which is only forecast out through through the early morning of October 11th right now. So let's look at this yesterday evening's model run and see how it might be a little bit different from this early morning's run. Where here's the ridge that's going to be moving onto the west coast this week. Here is that upper level trough, the upper level low, moving into the Gulf of Alaska, but we see it's a lot faster, a little weaker than this morning's model run. We do have some. If you look here, we have some. If you just look at these cooler colors back here, basically this means that there's more energy in the atmosphere moving in on the backside of the first low. And what that does is it gets absorbed into this low, and basically this low starts to rotate around it, makes a larger low there, and can pull some warmer air up on its east side. This is for October 8th. And then as we get later into the week, right there. Okay, so right here, as we get later into the week, basically the main difference here in between these two is how is all this energy that kind of consolidates over the north part of the Pacific, where exactly is it going to set up? How strong will it be? Will we get these areas of energy, which basically are these lows here? I don't know. There's no L marked right there where I just marked an L, but if you see all these black lines being really close together right here, I can't really draw that right there. Let me see if I can draw it in the red. Well, I'll just circle the area. So this area here, see all those black lines really close together. That means that there's a low pressure system developing right there, right along the boundary between this cool area here and all this warm air down here. And so there's energy being generated in the atmosphere, which is generated between that difference between that cool air and that warm air. And as we get these little areas of energy generated in the atmosphere, are they going to move up that way? Are they going to move toward the northwest? It's those slight little differences that these models are currently struggling with that far in advance, and that's what happens this far in advance. but most of these models do consolidate a lot of cooler air. I shouldn't have drawn that far into the North Pacific and the Gulf of Alaska. Have some kind of ridge over here. Is it going to be over the Rockies? Is it going to be over the West Coast? Is some of the energy going to leak into the Northwest, and then we get a ridge further east? That's the main question at this moment. So let's look at some other. This is we're gonna look at some of these ensembles now. So this is an ensemble. What this is an average of many different forecasts, and I'll actually show you a whole bunch of individual forecasts here in a little bit, so you can get an idea of how much they actually can differ this far in advance. But here, this is the European ensemble. EPS means European Prediction System. So it's just a system of a whole bunch of different models. And they're all run on the European model. What happens is we don't know what the exact atmosphere looks like right now. We have a bunch of observations all over the place, but there are a bunch of places, especially out over the ocean and up above the surface, where we don't know exactly what's going to happen. And even in places, we don't know exactly what's happening right now. Even in places where we do have observations right now, instruments have errors. And so if some instrument says it's 90, it's say like it's 75 degrees outside. If the instrument error is plus or minus 0.5 degrees, that means that it can be anywhere between 74.5, 75.5. And those little errors can actually magnify a lot in time. So what these ensembles do is they try to take those errors into account, whether it's where we do have observations and they're instrument errors, or where we just don't know what's going on, what's going on in the atmosphere, because we don't have observations. So they're basically making their best guess, which is basically interpolating in between observations. And so they adjust those initial conditions a little bit. And as this model runs, those little errors get magnified into bigger and bigger errors over time. So what we're looking at here is we're looking at an average of all those different possibilities that may happen. So often when we average things out, we're just going to see maybe a straight line, in terms of the flow. Like, all the colors will be a straight line east to west. Because if we have, this isn't the best example here, but I'll show you. Well, let me actually go to the end here. So here, this is a forecast for from last night. I wonder if this morning's is out quite far enough yet. Morning's is out. Okay. So this is actually this morning's model, and actually this is for the early morning of the eclipse, which I didn't pull this exactly. I didn't pull it for that reason, but you see how these colors are more or less in a straight line. This does not necessarily mean that our wind flow. This is actually above the surface. This doesn't mean that our wind flow is going to be west to east. There could be a model that is forecasting, a big ridge where we have all this warm air moving north. There could be another model that is forecasting a big trough, which is all this cold air moving south. And so one model could be forecasting very warm conditions. Another model could be forecasting cool and clouds and storminess across the center part of the country. But if we have just two different models, just for simplicity's sake here, and we average them out, we get a forecast that's straight west to east. So the further out that you get in time, the more likely you're going to see this straight flow like that. But if you see anything where we have um, cool air dipping south a little bit, and that's not the color I want to use. If we see anything where we see cool air dipping south a little bit like that, um, or even a little bit of a ridge here, where we have some warm air moving north, and that means more models are full, more of these. Um, like I said, it's the same model, it's just run multiple times. More of these individual runs of this model are forecasting a trough here, for example, than are not forecasting a trough. More are forecasting a little ridge here than are not forecasting it. So that's basically what that means. So that when we get the average, it averages out to a little bit more of this warm air moving north than just straight west to east flow. Or in this case, instead of straight west to east flow, it averages a little bit more of this cold air moving south. All right. So when we get this far in advance, we're seeing this is 360 hours. This is 15 days away, which again is Eclipse Day. The averages for a high pressure system at the surface here, off the coast of California, which is not surprising. This is the Bermuda High out here in the Atlantic, and this is the Pacific High out here in the Pacific Ocean. So this is a near constant high pressure system out here in the ocean. But whether it's ends up a little further south, and we get some energy coming in from the north, or whether it ends up a little further north, these ensembles really can't, with more of a ridge along the west coast, these models can't really figure that out precisely this far in advance when you average all these out. But little fewer more models, little fewer more. That's not the way I wanted to say it. A little more models are forecasting a trough over the North Pacific than are not forecasting one. This is basically what I was showing you before, of how we kind of have an agreement on some energy here in the North Pacific off of Alaska. We just don't know exactly how far west or east it's going to be. The average right now is for a little bit of a trough here, just over the Northern Rockies, according to the European ensemble average. Let's look at the GFS ensemble average. This is the GEFS, the Global Ensemble Forecasting System. That's the afternoon run. It's not out yet. So you can see here in the short term, and I didn't show this for the European model, but in the short term, they agree on this ridge. It's a lot easier for them to forecast and for them all to agree here in the short term than it is in the long term of this ridge moving into the northwest, into the west coast, I should say, basically, because it includes California. And then as we get further into the future, the agreement breaks down, but we also see how they are all agreeing and averaging on this cooler energy moving into the Gulf of Alaska and the North Pacific. This high pressure system actually moving a little further south. Of course, this is October 10th. Just go a few more days out here. The day of eclipse, you see that high pressure system in the Pacific moving a little bit further north than it was, but this is that same high pressure system, which is pretty much semi-permanent is what they call it here. But on the day of the eclipse, here is that North Pacific energy, and here is that little bit of a ridge that the models are currently averaging east of the Cascades into the Rockies. Again, this is an average. Let's look at the other ensemble, which is the GEPS. This is actually the Canadian ensemble, which is a little less accurate. You should look at this one as much. Sorry, Canada, but the models aren't necessarily as accurate. A lot of times, the resolution sometimes isn't as good, but it also has this energy consolidating over the North uh, Pacific, and then a little bit of a ridge here east of the Cascades again. Again, this is just an average, so it's not. This is not exactly what's going to happen, but there's been some good agreement in the trend on this energy, like I said before. Whether or not some of that goes into the northwest for some cloudiness and storms, or whether it stays a little bit further to the west and allows some warmer air and some clearer skies to move into the west coast, is still quite a ways away here at 15 days to be able to really, um, to be able to say for sure, obviously. Here's another way to view uh, the U.S. long-term ensemble model. So this is a forecast for when the eclipse is going to be uh, greatest off the coast of Mexico, so a few hours, maybe an hour or two, I guess, after it's over the northwest. And again, we see that cooler air over the North Pacific and a ridge building off to the east, and maybe a trough along the east coast of the United States at the same time. So let's just view a general map of average cloud cover. So if we look at the U.S. model ensemble forecast, and we say, okay, what is it forecast for an average cloud cover across the United States? This is, go back 6 hours, okay. So in between these two images, that one and then this one, is when the eclipse actually passes through the western part of the country. So the center of the eclipse, the annular eclipse, basically goes um, roughly like this, and then it continues southeast into the Yucatan Peninsula, Central America, and northern South America. But this, I'm focusing on the United States, and that the current average from the United States model has that energy close enough to the west coast to bring a good chance of clouds west of the Cascades. If we look at our mouse, if we put our mouse over this, we see basically a 70% chance, 65 to 70% average cloud cover over the Willamette Valley of Oregon, which is basically where the eclipse comes ashore. A little higher up in Washington, but up in Washington, you'll see a partial eclipse here. Once you get east of the Cascades, the average cloud cover goes down to about 40%, and then even less as we go into the southwest part of the country, and maybe a little more again as we get into Texas. So, based on what I've seen in past days and the current overall weather pattern setup, a very rough forecast. Again, this will change 15 days in advance. Is probably some clouds likely in this part of the eclipse, the eclipse path. And again, I'm circling Washington because you'll see a pretty good partial solar eclipse if you can see it in Washington. But I'm a little concerned about west of the Cascades there, given how close. If we see that northern Pacific energy start moving into the northwest, that could mean we could get some rain, we could get a cold front moving in. If that stays a little bit further west, we could have more we could have potential for clear skies. But the other thing about October is this is going to be an early morning eclipse, fairly early morning, where the sun's only going to be about, I think it was like 15 or 20 degrees above the horizon. It's only gonna be like it's going to peak about 2 hours after sunrise west of the Cascades. So it's going to be fairly low in the sky. And in the morning, what I'm also concerned about here in October is fog, low clouds and fog in the morning, even if we end up getting a ridge, or if the west coast is on the eastern side of a ridge, if we get a ridge, that basically centers over the Rockies here. And if you look at what I drew, that pretty much matches not only the cloud cover picture, but also what we kind of see in some of those um, averages. The west side of this ridge here is probably going to see a little more onshore flow, as our upper airflow and even some of our lower airflow comes more off the ocean. If that ridge was to center a little further west over the west coast, we'd have a much better chance of clearer skies west of the Cascades. But in October, when we have on this western side of the ridge, we can get a lot of onshore flow. We can get low clouds at night and in the morning. Even if we have a chance of skies clearing in the afternoon, that's going to be too late for an early morning eclipse here. So I'm worried about fog development. So I'm thinking west of the Cascades. At this point, again, it could change here. Uh, so it's still 15 days away, so there's a lot to be worked out here. Um, Probably some clouds as of this forecast here. Again, this is a 15-day. I have to keep saying that just so you don't, just so no one plans on this. But for sure at this moment. But I think the greatest chance of not seeing clouds will probably be here in Nevada, Utah, down to western Texas, and this is pretty much a climatological forecast too. This is which basically means if you base your um, forecast viewing on what normally happens, this is pretty much what normally happens too. But October can be pretty reliable in the western part of the country in that way. Uh, the greatest chance of clearer skies probably in this area at the moment, basically Nevada down through western central Texas. Could see a few clouds down here in southeast Texas. This depends a lot on tropical moisture. I think most of the tropical moisture, from what I've seen, as you see in this map too, is probably going to go northeast into Florida. But um, in this general pattern, if this pattern actually works out here. So people in Florida may not be able to see the eclipse again. It's partial there. East Coast, you may have a trough in the East Coast in the Northeast there, and if you do, you may not have a good chance of seeing the eclipse here Northeast. But it's a pretty small partial eclipse for those in the Northeast anyway. The main show in Northeast is April 2024, obviously. So you're probably not as concerned about this eclipse there. Midwest, you see a little bit more of an eclipse there, but the weather would be a little more questionable because it depends exactly on where that ridge and that trough sets up. And then, of course, in between these two areas, here in central to southeast, south central Oregon, it's a little more of a toss up. Because if we get a cold front that moves far enough east, it could bring some clouds over the Cascades. But if not, you're far enough away and on the other side of the mountains to be in that low clouds from the ocean, but you can still get some fog there east of the Cascades. So this far in advance, it's really tough to tell, especially there. But all of these. That's just the forecast, very rough forecast, 15 days in advance. So we will keep looking at this, and in my future videos, I probably won't go into all the little details that I kind of went into here. probably just give you a general overview of how things have changed since the last video. So that is September 29th, 15-day, very rough overview. This is meteorologist Luebcke-Eckstein, and I will talk to you soon.